what's up, scholars? Today we're going to talk about similar triangles. To do that, let's do some review of our properties of proportions. So let's make a proportion here. If A over B equals C over D, there's our proportion, two ratios equal to each other. We can use our cross product property to say what? You're right, A times D equals B times C. AD equals BC. It's our cross product property. It's what it is. Great stuff. Let's use that same ratio again. If A over B equals C over D, then we can use our reciprocal property to say what? That the reciprocal is true. We're going to flip each of those ratios. So if A over B equals C over D, then B over A equals D over C. The reciprocals are also equal to each other. Number 3, if A over B equals C over D, using our mean switching, switch the means. What were the means again? Oh, right, the numbers in the middle. Like the middle here, the B and the C. B and the C are the means. We can switch those two. So A over C will equal B over D. We can switch those numbers, and the same thing is going to be true. Why is that? Well, because when we use our cross product property, A times D equals B times C. That's the same thing we're going to get. We do A times D equals C times B. It's the same thing. Cool. And finally, A over B equals C over D. We said we could add the denominators to each side. Let me say that again. We could add the denominators to the numerators on their respective sides. That's what I'm actually trying to say. So I could add B to A, and I could add D to C, and it would still be true. A plus B over B equals C plus D over D. You can add the denominators to each of their respective sides, and it will still be true. And you can prove that to yourself with the cross product property. I'm not going to do it here, but you're more than welcome to go for it. All right, so let's remind ourselves of what similar figures are. There are two polygons such that their corresponding angles are what? Congruent. The corresponding angles are congruent, and the lengths of their corresponding sides are proportional. And remember, our symbol for is similar to is this tilde. Very good. So let's do an example of where, let's say, triangle ABC is similar to triangle DEF. And let's go ahead and draw some similar triangles. Call that guy ABC. Let's call this guy DEF. If they're going to be similar, their corresponding angles need to be congruent. So A needs to be congruent to who? D. B should be congruent to who? E. And C should be congruent to F. Their sides should also be proportional. So we can write a statement of proportionality. AB over its corresponding side. AB corresponds to side DE. That's going to be equal to BC over its corresponding side EF will be equal to AC over its corresponding side DF. So notice all the sides related to triangle ABC are on the top. All the sides related to triangle DEF are on the bottom. Great. that proportionality, it's an extended equation because it has equals that relates all of the equal ratios in a polygon. For instance, if we said triangle XYZ is similar to triangle VUW, we'd have the following statement of proportionality, which you are going to fill out because you and your big fat brains definitely know how to do that one. It'll be good practice, right? For sure. All right, once you finish with that, we're going to go on to the next page. Ready? Oh, that was so quick. So fast. And this one says, on your own. Write the whole thing on your own, the statement of proportionality, and list all the pairs of the congruent angles for the following similar triangles. If triangle ABC is similar to triangle XYZ. Awesome. You get some more practice. You know, math is like mental weightlifting. You got to do your repetitions to see any of them gains, right? Do you even lift, bro? Yes, we definitely lift. Super strong. All right, now that you have written out your congruent angles and your statement of proportionality, just as when we looked at triangle congruence, there are some shortcuts to help us remember if triangles are similar. We got some shortcuts. What were our shortcuts for triangle congruence? Triangle congruence. Right? We didn't measure every single side and every single angle to prove that triangles were congruent. We said if you know all their sides are congruent, triangles are congruent. If you know a side and an angle and a side, the angle between two sides, if that's congruent, then the triangles are congruent. We said if you know a side between two congruent angles, it was congruent. If you knew two pairs of angles and a side that was not between the angles were congruent, then the triangles were congruent. Or if you had a right triangle and you knew the hypotenuse, and the leg of those triangles were congruent, then the triangles were congruent. Right? We didn't measure every single little thing to prove that the triangles were congruent. We're going to do the same thing with similarity. So we have the angle-angle similarity postulate, which says if two pairs of corresponding angles are congruent. So let's say if K is congruent to Y and L is congruent to Z, then the triangles are congruent. If two pairs of angles are congruent, then the triangles are congruent. This only works for triangles. The reason it works is if two angles are congruent, two pairs of angles are congruent, then the third pair of angles has to be congruent. Why is that? Well, the angles in a triangle add up to 180 degrees. So if these two angles are congruent, these two pairs of angles are congruent, their third angle has to be the number to make these two add up to 180, and it'll be the same number over here. And then voila, we'll have two triangles with all their angles congruent, and they have to be similar. So we don't need to measure all three angles, we really only need to measure two. And the third one will be congruent as a consequence of that. So angle-angle similarity postulate. Bum, ba-dum, bum. Ooh, let's do an example to explain why the triangles are similar and write a similarity statement. We're going to write us a little two-column proof, bringing it back. Some statements and some reasons. Statements and some reasons. All right, we know our first reason is going to be given. What are we given in here? What's written for us in this picture?